Hello there. So welcome back to the engineering mechanics video lectures. So far we have seen the different types of the concepts to find out the field parameters, the field quantities of velocity, displacement as well as the acceleration of a body. So in this case we are trying to introducing the new topic that's going to be work energy method. So in this method we are going to be trying to find out the same parameters. When an object is going to be moving, then how I can correlate this work is equal to the energy, and so that I can develop the equations of that. Suppose, so initial stage we are trying to find what is the work done by the particle or work done by the force. Once we are going to be frame that kind of equations, it will help, and next we are going to be framing the energy equations, right? As we know, when the work is going to be developing, that's because of the physical work. The second one is going to be the gravitational work is there. And similarly, in this case what will happen, energy we do have the possessed by a body, right? That's maybe the potential energy or maybe the kinetic energy. So in this case what will happen, the work is nothing but, we do have a standard formula that's going to be, work is going to be force into the displacement we are going to be saying. The force into displacement. Then what is the energy? The energy is nothing but capacity to do work is called the energy. Right? Now I am going to be identifying the work done by the particle when there are going to be different types of the situations is existed. So here is the first concept. There we can see when work done by the force. In this case we are going to be considering this is going to be the physical force, right? Now I am going to be considering a particle. So here I am going to be considering this is going to be the particle, and the position of the particle is the A. So it is located at A, right? If the particle is going to be subjected to a force F, right? So then the body is going to be, this particle is trying to taking to the new position. It means a small displacement is going to be taking place because of this force. So the distance I am going to be say A to B, that's going to be a small displacement is the ds. Then it means that because of this force, the particle has traveled from A to B, the distance is the ds. Now what is the work done by this system? So in this case we have the formula that the work done is equal to force into displacement. That's what we are saying. So in this case what will happen, then we need to understand here, this force, applied force is going to be inclined to the displacement vector. It's making an angle of theta, right? So in this case what will happen, when it is making an incline to the displacement vector, we need to resolve that force into two. One force is going to be acting in the vertical upward direction because this force is moving in this direction, right? And another force is going to be acting along the direction of your displacement vector, right? And when I am going to be resolving this is, I am going to be say F sin theta, I got it, and similarly the horizontal component F cos theta, I got it. So in this case the two resolution of the forces are available. Now which force is going to be imparting the motion to the particle? There we can see F sin theta, it is always acting normally to the displacement vector. So then I can say this is not going to be applying any displacement in this direction, the displacement vector. But there we can see the horizontal component F cos theta, which is parallel to the displacement vector, and due to this reason this F cos theta is going to be imparting the motion to the particle from A to B. So the same equation for these situations I am going to be converting the work done. So the work done is equal to, here what is the formula? F cos theta. This is the force vector we got it, and similarly it has a traveled distance of ds. So now we are going to be, we got it, the force into the displacement. We have taken only a small elemental displacement only we consider. If you are considering the throughout the process, So the same equations, that's work done 1 to 2 is equal to integral 1 to 2 f cos theta ds, I will get it. So from this equation I can calculate the total work done by the force or total work done experienced by this particle. I can calculate from this equation. Is clear? So this is when a physical force is going to be acting on a particle, and this is going to be the way we are identifying the work done by the particle. So the second force we are going to be considering here is the gravitational force. When the body is going to be subjected to the gravitational force, and what kind of work done it can generate it. To illustrate this one, the first I want to define what is the gravitational force. That's going to be its F is going to be trying to pull towards its center. So that's we are going to be saying here is going to be the gravitational force. So in this case what will happen, the gravitational force, it means that each and every particle which is existed on earth, it's going to be subjected to the gravitational force. And due to these reasons we are unable to get the escaping velocity from this earth surface, and we are going to be sticking to this part. If you are getting the escaping velocity, means the gravitational force is not going to be acting automatically, and we are applying the artificial forces so that it can escape from this. And for this one I have taken a mass of the particle m, and then it's trying to move in the vertical plane. Suppose this wall is going to be your vertical plane, right? And in this case, when the gravitational force is going to be acting on your body, when the body is moving either the vertically upward direction or vertically downward direction, then only the particle is going to be subjected to the gravitational force. When a body is moving in the horizontal plane, then the experiencing of the gravitational force is going to be not that effect. So I considered a particle of mass m, and it is trying to, the path I have taken in the vertically upward direction or vertically downward direction. Then assume that it has traveled at a distance of, and then it is going to be coming to the earth. So consider this is going to be the ground. It has traveled a distance of dy, I am going to be say, or some people they will say dh distance also they are going to be considering. Alright. So what is the work done by the gravitational force of this one? Right. So same equations I am going to be writing. The work done by this gravitational force, that I am going to be taking F into, that's going to be the gravitational force that's acting in the downward direction. So that's into dy I am going to be taking. Here what is the F? The F is nothing but that's going to be your gravitational force, that I am going to be taking W into dy. The W is nothing but that's going to be the weight of the object. That weight itself is going to be, it is subjected to the gravitational force. And further simplification of this one, mg into dy I am going to be taking. If you want to calculate the total work done by the gravitational force, is going to be work done 1 to 2 is equal to integral 1 to 2 mg dy I am going to be considering. And finally I am going to be getting here mg y2 minus y1. Right? So on this basis we are going to be calculating. Suppose sometimes if any one parameter, in this case y2 or y1, is going to be 0, the simple simplification of this equation mgy we will get it. Right? The same equations we are going to be writing mgh also. Right? Any one parameter we are getting. The work done by the gravitational force 1 to 2 is equal to, that's going to be mgy. The y is nothing but your vertical distance traveled from this position to this position. If you consider this is going to be the 1 and this is the position 2. So on that basis we are going to be derived. Now here is the one more concept, work done by the spring force or work done due to the spring force. As we know that, there we can see I have given the one example. Here is the block A, which is connected to O through the spring. Right? As we know, we do have certain terminologies we are using in this case, and K is going to be your stiffness of the spring. Stiffness of the spring. Right? F is going to be your spring force. This generally when it is going to be exact to the certain displacement on the spring, and x is going to be the displacement of the spring. Displacement of the spring. So we are assuming that the body is at the equilibrium condition. So in this case, what will happen? The external forces acting on that is equal to the internal forces are going to be developing, and presently it is in the equilibrium conditions. Then what I am going to do? I am going to give a small displacement to this block A. So then what will happen? The spring is going to be started to elongate by taking the force in this direction. So can you see, this is going to be the block A. It reaches to this position, to this position. I am going to give this x. So as we know that this x is going to be the displacement of the spring, and it is going to be subjected to the force of F in this direction, F. So then the same, what is the resistance force is going to be developing in that spring is equal to your applied force. That I am going to be taking F is equal to, I am going to be taking the stiffness into the displacement. I am going to be getting, here is the internal resistance, that is going to be the spring force I am going to be getting. After certain time, what will happen? The spring started to deform in this direction. Then if I am going to removing this force, then what happened? The body is going to be start to exerting the force exactly in the opposite direction. It means that the body is going to be trying to back to its equilibrium position. So then what will happen? The distance traveled here I am going to be taking, this is the part. So the distance that traveled by the body, then finally I am going to be taking the work done equation. So here the work done 1 to 2 is equal to, that I am going to be taking F into dx. I am going to be taking F here is going to be the spring force. That's going to be K into x into dx. We are going to be taking, and the total work done we are going to be calculating integral 1 to 2. If I am going to be start integrating this part, so I am going to be getting here, that's going to be K is going to be the constant, K into the x into dx is going to be x square by 2, 1 comma 2. Then final simplification from this one, the work done is equal to 1 by 2 K into x2 square minus x1 square. So this is the equations we generally use to develop when a body is going to be, or a spring is going to, the spring force is going to be acting on a block, that the spring can develop this amount of the work. I hope you are able to understand the concept of the work done by the physical force, the work done by the gravitational force, work done by the spring force. So by using the concept of work done is equal to force into displacement. If you know what is the force is going to be acting in any of these three or any other forces, sectional forces also. So on that basis we are going to be calculating the total work done on the system. I hope you are able to understand. If you feel any difficulty, so please put in the comment section so that I can reach to you by making by clarifying the doubts. Thank you.